let's talk about surfaces. What do I mean by surfaces? Remember that in 2 dimensions, we would only need x and y to get a point. So we'd only use the xy plane. Now, what did that look like? So you would have a Cartesian plane like this, whereby you have the x and you have the y, and then you would have a line, or you'd have a point, or you'd have a nice flat plane right there. So that was in 2 dimensions. But let's say now you want to deal with 3 dimensions. Now in 3 dimensions, we don't only need x and y, we also need z. Now we introduce a 3rd dimension to our Cartesian plane. Now if you look at this axis here that I drew, this axis is coming out of the paper, coming outwards towards my camera here, or going into the paper. So we can draw it like this so that you can see it. We'll have z there, and then we'll have y here, and we'll have x here, and there will always be 90 degrees to each other, meaning that they are normal to one another. Now let's say that I wanted to draw 1 equal to 3, and I wanted to draw it in 2 dimensions. Now to draw y equal to 3 in 2 dimensions, I would have my Cartesian plane here, y and x, and then I will go up to 3, and then I will draw a line at 3, because y equal to 3 represents all points on my Cartesian plane whereby the y coordinate is 3. So what if I wanted to draw z equal to 3, and I wanted to draw it in 2 dimensions? Now I can take from this Cartesian plane, I can take y and z, and then see that z at 3 will be equal to, z at 3 will represent a line where it shows all the points on the Cartesian plane that are equal to where the z coordinate is equal to 3. But with surfaces, what if you wanted to draw y equal to 3 and z equal to 3 in 3 dimensions? How would that look like? I want to draw y equal to 3, and I want to draw it in 3 dimensions. So the first thing I would do, I would draw my Cartesian plane. Now it will look like this. I will have my y here, and I will have my x there, and then I will have my z going up. Now I will have my z going up like that. Remember right hand rule. Y equal to 3 will be situated right here. So I will have y equal to 3. Now in 3 dimensions, this does not only represent a line. We want all the points that are where the y coordinate is equal to 3. So how do we show that? So it will go something like this. Then we'll go up, and then it will come down, and then it will come all the way down. Now we call this a surface, and this surface cuts this point at y equal to 3. Now if you have a difficulty seeing it, you can tell that it is a flat surface that is parallel to the xz plane. So you can have another plane on top of the x-axis, and it will go something like this. So it is parallel to the plane. So y equal to 3 will cut at 3. It is the blue part, and it will form a surface. So it will represent all the points that have the y coordinate that is equal to 3. That represents all the points in z and all the points in y. So every point on this surface as long as it has a y coordinate equal to 3, it falls on top of that surface. And that's what y equal to 3 will look like. So this is y equal to 3. We represent it by saying x, y, z in y equal to 3. You can see that in the two-dimension drawing, this line is actually this surface. We're just looking at it in just 2 dimensions. So if you look at it coming from upwards, which is x and y, if you look at it coming from this direction, you will only see it as, if you look at it looking at that direction, you will only see it as a line, but it's actually a surface that goes into the z-axis. Remember, the z-axis come out and go into the paper. So if you look at it in one direction, you only see a line, whereas if you actually look at the third dimension, it becomes a surface. So this has always been a surface, just being looked at in one dimension. So let's attempt the same thing and try to look at the z equal to 3, but now let's draw it in 3 dimensions. So now we can see if it is a line and we're only looking at it with 2 dimensions here, that means that the third dimension that is coming and going into the paper, it must be a surface. So let's draw it. The first thing I'm going to do is to draw my Cartesian plane. So what I'm going to do is draw my y-axis. Let me extend them. Draw my x, and then I have my z. Now my z go up, but I want to do something here. Now since z is equal to 3, it will be a surface that hovers around somewhere here. So it will go like this. And then I have my z over there. Oh, my drawings are so bad. So z equal to 3 will be this surface that is right here. It is equal to 3. So it will cut the z-axis at 3, and it will be parallel to this axis, the x y axis down here. So these axes, it will be parallel to them. So we're basically taking that plane and then moving it 3 points up to the top. You can see we did the same thing here, whereby the distance from here to here, it moved 3 points. The same thing, the distance from here to here will be 3 points. So in 3 dimensions, z equal to 3 is a surface that represents all points whose z coordinate is equal to 3. So it must cover the y-axis and the z-axis, and it must be lying on top of that. It continues infinitely. I just don't have the space to do that. Now we represent it the same way as we did down here. It will be given by x, y, z, and then you say z is equal to 3. The way that we say it is that it is all points in R3 whose z coordinate is 3, and it will make a surface like that. Let's take an even more interesting example and say we wanted to represent the point x squared plus y squared equal to 2, but we wanted to do it where z is equal to 3. Now the way that it looks is that we start with our Cartesian plane. You have your y and you have your x, and then you have your z. You know that x squared plus y squared is equal to 4 represents a circle with the radius 2. So if you were in 2 dimensions, this will look something like this. You would have a Cartesian plane of x and you would have y, and then your circle would go around like this with a radius of 2 in each side. Now the thing that you may not have noticed all this time is that there's a third dimension coming out. So this circle is actually going around xy like this with the z-axis as its axis of rotation. So now that I have x squared plus y squared equal to 4, but my z is equal to 3, it means that I have the same type of circle with the radius 2, but now it comes up in this axis. So it will go up in the z-axis at z equal to 3. So it will roam around somewhere like this. So I bring out my axis now, and then it will come out of here like this, and then my z will be equal to 3 at that point. And now you have a circle with a radius of 2. So it represents a surface where r is equal to 3, and that surface is a circle. Now suppose that we were not given z equal to 3, we were just being told that in 3 dimensions draw x squared plus y squared plus 1, for instance. Now the first thing that you always do, you will draw your Cartesian plane. Now here's my thing. If you have a circle here, now this circle is only at 3 because we were very specific that z is equal to 3. If we do not specify that z is equal to 3, this circle will occupy this entire z-axis. Just like here where we didn't specify in 2 dimensions, this circle goes all the way up and all the way down. So it will look something like this. Take for instance x squared plus y squared plus equal to 1. It will be a circle like this with a radius of 1. Your radius is 1. But because it's in 3D, it will occupy that entire space. It will go for infinity all the way down and all the way up, because we don't know the bounds of z. So you will have your z-axis coming out of here like this. You have z and you have y. Y goes all the way inside like this, and then z comes down here, and then your x will come out something like this. So that's your x, y, and z. So because we didn't specify the z, here we restricted our circle at z equal to 3. Without that restriction, our radius will exist everywhere in the z-axis, but it will be restricted in the y and x by its radius. So it will be cut at 1 here, at 1 here, at 1 at the back, and at 1 at the back there. So it will be your nice looking cylinder like that.